To simplify radicals using the product rule, we are looking for perfect square factors of the radicand that we can extract outside of the square root symbol. So the first thing to do would be to rewrite the number under the radical, the radicand, as a product of two or more factors. And those factors, one of them should be a square factor, and you should list that one first. So I know that if I look at 18, that's 9 times 2. And 9 is a square factor. So I'm going to write this as the square root of 9 times 2. Then I'm going to break it up further into the square root of 9 times the square root of 2. And then I'll solve it vertically by simplifying. The square root of 9 is 3. The square root of 2, it cannot be simplified any further. So my answer here is 3 times the square root of 2. To simplify or to check any radical solution, we're always going to take this number and raise it to the power of the index. Well, the power of the index was 2. So we're going to take 3 radical 2, raise that to the second power. Well, that would be like taking 3 to the second power, which is 9, times the square root of 2 to the second power. Well, the square root of 2 times the square root of 2 equals 2. Well, that's 9 times 2, that's 18. That was our original radicand, so I know that this is simplified correctly. We take the number outside, we raise it to the power of the index, so 3 squared is 9. We take that number, multiply by what's under here, and we should still get the same number. Okay? We'll do that here with the square root of 12. We're going to use the product rule. So we're going to re-express 12, square root of 12, as the square root of two numbers. Now when I think of 12, the first two numbers I think of are 6 times 2, but neither of those is a perfect square. But 4 times 3 starts with 4, which is a perfect square, so that's the number pair, the factor pair I'm going to use. I'll re-express the square root of 4 times 3 into the square root of 4 times the square root of 3, and then I can simplify these vertically because the square root of 4 is 2, and the square root of 3 cannot be simplified, so I'm really looking at 2 times the square root of 3, or 2 radical 3. To check that, I can always take my simplified form here and raise it to the power of the index. So 2 radical 3, we're going to take that whole thing and square it. So that's really 2 squared, which is 4. And then the square root of 3 times the square root of 3 is 3. Well, that's 4 times 3. That's 12. That's our original radicand, so we know that we have simplified this correctly. Another way to check that would be to take this number, raise it to the power of the index, which is 2. So 2 to the second power is 4. 4 times 3 is the original number. Now we have the square root of 33. So we're going to try to arrange this or simplify this according to the product rule. So the only two factors of 33 that I can think of are 3 and 11. 33 and 1 don't count. But 3 and 11, neither of those are square factors. So no matter how I would simplify this, if I were to do the square root of 3 times the square root of 11, neither of those are perfect squares. If I wanted to do the square root of 33 times 1, well, we don't list the number and 1 as one of its factors when we're trying to do this. So none of these would be acceptable. The square root of 33 is already simplified the way it is because it doesn't have any perfect square factors.